KS4 668, pattern 3.
Roger, pattern 3.
Well, that's it for us, Ken. You get all the pictures you need?
Yeah, I think I got some good ones. So, what happens now?
Oh, we take all the seismic data we recorded and send it into processing.
You think they'll be making hole out here?
Oh, it depends on what they find in the processing. If they like what they see, they'll go ahead and drill a hole out here. If not, they'll just go someplace else.
I see. Well, I appreciate it.
All right,
we'll see you.
We've run our seismic survey off of this gas field here, and the structure's showing that we're dropping down on both sides of this fault and stepping up here. The structure's also showing good rollover and closure into this fault, so it's my feeling that this would be our best location to drill that well.
How do you know?
We're not positive. The only way to know for sure is to drill a well. But the data looks real good.
The seismic data.
Right, the seismic data gives you an indication of your formations in the subsurface and your structure in the subsurface. So instead of just taking a shot in the dark, you got a lot better chance of finding an oil or gas producing field.
How good?
About 1 in 9.
That's good.
Well, it's a lot better than it used to be.
So, what happens next?
Well, it'll take us a couple of weeks to line up a drilling contractor and get someone out to survey our location, but before long, we'll definitely be making hole.
Mr. Summers, you need to sign these letters. Have a downtown meeting at 2 o'clock. Offshore's been calling all morning.
Yeah.
And your budget committee meeting is waiting.
Lee, can I talk to you for a minute?
How's the drilling project?
Yeah, the drilling project.
We already have an in-house presentation on drilling. Ken, you know that as well as
Yeah,
I do.
I know, but I've already completed research on the seismic testing, and geophysics tells me that there's...
Summers.
Lee, the drilling department just called me and said that now is the perfect time for me to be out there getting the shots I need.
Slow down. Now, one more time. Tell me what it is you want to do.
I want to make an interesting presentation on drilling. I've got an idea that I know is...
Budget meeting is waiting.
Lee, they're out there drilling right now.
Okay, Ken, do it.
Thank you.
Ken?
Yes, sir?
Better be interesting.
Just a little bit.
Good morning, Roger.
Morning, dude.
Care for coffee? Yeah, I need something to open my eyes. How you doing? Good. How about you? Wanna wake up for coffee?
Thank you, yes. Roger, thanks for getting me out to this rig. I really appreciate it.
No, it's no problem. You've been up to a rig before, anyway, haven't you?
A few times, but never for anything like this.
Well, tell me about this program you're putting together.
Well, I'm trying to put together a slide program on drilling a well, and it's going to include everything from exploration to drilling to circulation and mud logging.
Whoa. That's a lot of territory. You're going to need some help.
Well, I think that's where you come in, Roger.
There it is.
So what do you do out here at the rig, Roger?
Well, they call me the company man because I represent the company that's financing the whole project. Now, on the rig, they call us the operator. Anyway, when we start to drill, we hire a drilling contractor.
Why don't you do the drilling yourself?
Well, you see, the drilling contractors, they own their own rigs and they specialize in drilling, and we don't. Yeah, I gotta get to work. Let's go. Read this, Ken.
Thank you. Do you mean to tell me this thing is actually portable?
It's not like a portable typewriter or anything like that. It'll take over 25 tractor trailer loads, but that whole rig's gonna move down that highway.
Now tell me, how do you pay the drilling contractor?
Boy, you're gonna cover the whole waterfront, aren't you? All right, let me see. There's two ways we can contract a driller. On a day rate or on a footage rate. Now, if we contract on a day rate, we pay a fixed amount for each day's drilling. Now, if we contract on a footage rate, we pay an agreed upon amount for each foot of hole they make.
Tell me now, have I missed anything out here so far?
Well, not really. This is probably as good a time to be out here as any, because we're going to be tripping out, drilling, and making connections. And you'll see just about everything we do out here.
Okay, well, if you excuse me, I think I'm going to go try to pop off a few pictures. This rig is gigantic. I've never seen anything like this. How tall is that mast?
142 feet. We're drilling at 22,000 feet, so we need a rig that big. Hey, don't get carried away. I want to show you something first.
Okay, okay.
Ken, this is what it's all about. Everything else you see out here is set up for just one purpose. That's to turn this bit to the right so we can make hole. Now these teeth cut through whatever formation we're drilling through. And believe it or not, these bits do wear out. Take a look at this old one here. See how the teeth are all worn and jagged here?
Uh-huh.
Now look at the new one again. See the difference?
You look at that long enough, you're liable to have to buy it.
Tommy, how you doing?
Just fine.
Good. Real good.
Motivated photographer I've heard about.
Yes, sir. I'm Ken Vincent. Nice to meet you, Tommy.
Nice to meet you. Like to look the rig over?
Sure.
How deep are we, Tommy?
13,340.
What's the penetration rate?
About 3 foot an hour.
Yeah, it's not bad considering. What's the condition of the mud now?
Well, we're getting a little more weight in it. It looks like looking pretty good.
Good.
Thank you.
What would you like to see, Ken?
Everything.
You come to the right place, make yourself comfortable. Time you think that casing's gonna be here?
I hope to get it out to you on Monday. Thought you might want to take a look at some of the other equipment.
Yeah, I keep forgetting I'm supposed to see the entire operation. It just seems like the rig floor is where all the good stuff.
I know, where all the action is.
Yeah.
Well, there's a lot more to drilling than just drilling. Circulating the mud, for instance. These steel tanks are mud pits. That's where we hold our drilling liquid, or mud. Now, you probably know by now that mud's made out of a mixture of water, chemicals, special clay, and a material called barite, which can add weight and density to the mud.
Yeah, that's the mud that lifts the cuttings up out of the hole and also cools and lubricates the bit.
Yeah, but even more important is the weight of the mud in the hole. It holds back the formation pressures and has a tendency to want to work its way back up the wellbore. But we'll get to that later. In order for the mud to do its job, we got to circulate it in the hole and back out. We do that with these mud pumps, 1,500 horsepower each. Now we pump it from here up to the standpipe, through the rotary hose, down through the swivel, the killing, all the way down the drill string. It comes out the bit, travels back up the sides to the surface. All right, then the mud comes down the mud return line and flows into our shell shaker. All right, now the shell shaker is the same thing as a sieve. It separates the cuttings from the mud. That's just one part of our mud cleaning equipment. Now you see the mud loggers taking samples of the cutting for analysis. All right, then the clean mud is pumped back into the pits and then it's recycled through the well once we've conditioned it back to specifications. This is our drill pipe. Now each one of these is called a joint. When you hook them all together, that's how we make up our drill string. Each one of these weighs about 25 pounds per foot. See that thicker pipe there? That's one of our drill collars. Now they can weigh 6, 8, maybe 10 times as much as a drill pipe. Now if you could see the drill string coming up out of the hole, you'd see the collar right above the bit. Now they add weight to the bit so it can bite into the formation. All right, we add a joint which is 30 foot of pipe at a time. Let's go on back up to the rig floor. I think it'll make a lot more sense this time. That's right, once we start drilling, we don't stop until we've reached total depth. On this rig is 22,000 feet. Now we work 24 hours a day, 7 days a week. On a drilling rig, a shift is called a tower and they're 8 hours long. Some contractors have 12-hour towers.
How many men on a tower?
Well, you've already met the tool pusher. Now, he's the drilling contractor's #1 man. He's usually on 2 days and off 2 days. But there's always another tool pusher to fill in, or there better be.
I can understand that. The tool pusher is the supervisor of the drilling crew, right?
Right. Now there's also the driller. There's a driller on each tower, and he supervises the roughnecks on his tower. He'll also operate the drilling equipment. He operates the draw works.
Now that's part of the hoisting system.
Right. Now the driller, he operates the draw works to raise or lower the drill string. Okay, see the wire rope on the spool there? That goes through the crown block and the traveling block. It acts like a giant block and tackle system that suspends the enormous weight of the drill string.
Okay, I understand how it lifts the drill string in and out of the hole, but how do you turn the bit?
All right, you see the Kelly?
Yeah.
All right, it's a pipe with 6 flat sides. It sits in the Kelly drive bushing and the rotary table. The driller turns the rotary table, it turns the Kelly, the drill pipe, and the drill bit.
But I thought there would be more people on the rig floor.
These guys got a lot of other jobs to do besides working with pipe. When we're drilling, the derrickman's not even up here. He's down here checking on the mud pumps or the condition of the mud. Well, one of the roughnecks is a motorman, and he's the one that handles the maintenance of the drilling engines.
Well, now, let's see here. Is it tool pusher, driller, derrick man, motorman, and 2 roughnecks. Well, that's 6. I still thought there were more people. Huh?
I'm the 7th, don't forget. Company man?
Oh, yeah, right. Operator's people. Well, who else have you got out here?
Well, we got the mud logger, and sometimes we contract a mud engineer.
Oh, yeah. We saw the mud logger at the shale shaker taking samples.
Right. Now, the mud logger examines the cuttings under an ultraviolet light for signs of oil. And he analyzes the mud for signs of gas, which could be a problem. Now, the mud engineer makes sure that the mud is the right weight to keep the formation pressures in check, and the right thickness and viscosity to lift the cuttings up out of the hole. If they're not the right specification, then he lets me know. Let's go take a look at how the whole operation is powered.
Okay.
First thing you need is a prime mover or power source. Now on this rig we got 3 900 horsepower diesel engines driving our electric generators. Now there are other kinds of power sources, but they all do the same thing. They transmit power to the main parts of the rig.
Which are?
Draw works and the mud pumps use the most power. The drill string weighs about 400,000 pounds, and we're pumping 500 gallons of mud a minute. We better have some kind of power. How's it going, kid?
Okay, everybody's being real helpful.
Good. You got enough information for the program?
I'm getting there.
Good. Tell you what, why don't we take time out and see just what you know? Use that rig posted there and tell me the main parts of the rig.
Okay. Here's your pencil.
Sure.
Let's start with the hoisting equipment that lifts the drill string in and out of the hole. We've got the drawworks, the crown block, traveling block, the hook, the elevators, and of course the mast.
Okay, not bad. All right, now the rotating system.
That's the system that turns the bit, and it's driven by a chain off the drawworks here. And it includes the swivel, the flat-sided pipe called the Kelly drive bushing, rotary table, and the drill string and bit.
Okay, that's good. Now you got one more.
Well, that would be the mud circulating equipment, and that includes the mud pits, the pumps, the standpipe, the rotary hose, and the cleaning equipment used for recycling the mud.
That's not bad, Ken. Really. Look, I got to finish this paperwork before we trip out. Don't be afraid to ask any questions. If there's something you don't understand, you find somebody to explain it for you.
Thanks for everything, Roger.
Okay. Sure enough. Ken, you might ought to watch this. We're getting ready to make a connection. All right, the first thing, the driller will stop the rotary and he'll raise the drill string. Then he's going to shut off the mud pumps to stop the mud flow. All right, the crew will set the slips to keep the drill string suspended in the hole. The crew latches the tongs around the Kelly to break it out. You see the spool on the end of the drawworks there?
Uh-huh.
It tightens the pull line to the tongs and it loosens the Kelly. Then he turns the rotary table and spins the pipe off the Kelly. The new pipe that we're going to add to the drill string is in the mouse hole next to the rotary table. The crew swings the Kelly over and stabs into the new joint, and then they make it up tight. They raise this over the drill string and stab it. They use the spinning tongs to spin up the new joint. Then they use the regular tongs to make it up tight. The crew then will pull out the slips, lower the pipe, and we'll drill ahead.
Well, Ken, making a connection, that's when your Kelly's all the way down. You got to put another piece of pipe on there to make any more holes, so you have to pick your Kelly up, set your slips, break your Kelly off, and make up the joint that's over there in the mouse hole.
What's that all about?
It's BOP drill, Ken. We do that once each tower every day to check the crew's reaction time during an emergency.
What kind of an emergency?
Kicks, possible blowouts. You know what a kick is?
Yeah, that's when high pressure tries to escape up the wellbore.
Right. Now look, our drilling mud has a very important function when it comes to blowout prevention. The weight of the column, the mud, and the hole keeps most of the formation pressures in check.
But when you hit high pressure formation, it can
That's
come...
right. We could have a kick. Now we're always looking for a kick, but if we don't anticipate them, they get out of our hands. And then we can have a blowout, and that's serious. All right? So we train our crew to be able to recognize the kick, what to do, and act fast.
Boys done good.
Thank you.
Minute 52.
Thank you. Appreciate it. Well, then that kind of training can really come in handy.
That's right. That's why blowouts are pretty rare. When a kick comes along, we're ready for them.
So what happens if you really do take a kick?
Well, if that does happen, the driller will shut the well in, the crew will go to their assigned stations, and then we'll use certain well control procedures to regain that pressure control.
Pressure control?
Let's go down to the substructure and I'll show you the blowout preventers.
Okay.
We call them BOPs. They're blowout preventers. Gigantic valves used to shut in the well. Now, they're stacked right on top of each other so that if one fails, we've always got the other three for backup. Now, some BOPs can close off the hole that doesn't have any pipe in it, some close off around the pipe, and some cut right through it.
Okay, so the BOP sits on the ground right over the hole.
Well, they are right over the hole, but they're bolted onto the surface casing. First thing we do is we drill to a predetermined depth, stop, trip out our drill pipe, then we line the hole with large diameter steel pipe that we call surface casing. Now this surface casing will protect the formations that might have fresh water in them, and it also prevents this hole from collapsing or caving in. Now we'll also contract a cementing company to cement the casing in. Alright, as we drill deeper, we'll run one or more strings of intermediate casing. Now this is also cemented in. Okay, now the cement prevents the fluid in one formation from running into another, and it also isolates our producing formations from the other zones.
Hey, Roger, that old bit's starting to act up. Look like we're going to have to pull it.
All right, Tommy, I'll be out there in a minute, all right?
You mean they're going to have to come out of the hole with all this pipe now?
Yeah, and in this case, it's going to be 13,000 feet. And when we trip out, the derrick man's got to go up on a monkey board.
Monkey board? What's that?
Now, the monkey board's where the derrick man stands to work the pipe. Now, the crew's already broken out the Kelly and put it in the rat hole. They've also unlatched the hook from the swivel. All right, now what they do is they check out the elevators.
The elevators are those latches there.
Right. Now, once the elevators are attached to the pipe, the driller can raise and lower the drill string. Now, what happens is that the crew disengages the slips, the driller brings out a stand of pipe, which is 3 joints, they engage the slips to hold the pipe. They use the tongs there to break out the pipe, spun around with a rotary. Then the crew sets the stand back over there. That's what we call tripping out.
Okay, now what's the difference between tripping out and tripping in?
Well, essentially it's the same thing but in reverse. It's just that you're putting the drill string back in the hole.
That's great. That's great. I know I got some beautiful shots out there.
Now, I told you it'd be a good week to be here.
This thing was at 13,000 feet. That's more than 2.5 miles down.
Well, we're here to make holes.
Well, what do you look for when you pull these things out of the hole?
Well, we check the teeth, check the cones, the wear and tear on the bearings to see how they perform. And we'll make up another bit and run it back down again. That's good.
Thanks.
Real good. You think you got all the information you need for the program?
Well, now there is one thing we haven't talked about. Testing and completion. How do you know whether or not the well's going to be a producer?
Okay, for one thing, the mudlogger looks at cuttings for hydrocarbon shows. That's signs of oil. We can also take core samples of any of the formations for anything that looks interesting.
Now, aren't cuttings and core samples just small parts of what could be an awfully big formation?
Yeah, but they do give us an idea. Now, we've got other methods, too. Drill stem test and well logs gives us a downhole information that we'll also use in the analysis.
Okay, so cuttings and core samples along with drill stem tests and well logs give you a pretty good indication of whether or not it's going to be a producer.
Yes, all right. And then there's the question of completion. All right, if you got enough natural pressure drives the gas or oil up, then we just install the valve tree.
Christmas tree.
Right, otherwise we just pump it out.
Oh man, it looks like testing and completion is going to be a whole new program.
You know, I think you're right. I think we need to go while we're ahead.
You leaving already?
Yes, sir. Jim's already here, and I've given him my drilling report.
Well, I guess we better get back up on that floor. We're still going in the hole real bad.
Well, I'll see you in a couple days, Tommy. Take care.
See you, Kim.
See you, Tommy.
By the way, how's that program going to turn out?
It's going to be interesting.
I bet it is.